everyone, and welcome to today's chemistry tutorial, where we're going to talk about chemical reactions and Molar calculations. In order to go through this topic, we will use this example, and in order to go through this example, we're going to use this checklist consisting of 4 points. So, first, we're going to read the example. If we had 1 gram of sulfuryl chloride reacting with 7.5 grams of hydrogen iodide, according to the following unbalanced chemical equation, which is this one, calculate the theoretical yield of water. So, I already wrote several times the equation so that I can write the stoichiometric numbers as we go. So, first I rewrote the original one, and I think we're going to go through it atoms by atoms. First starting with hydrogen, as it is the most abundant one in the equation. As you can see here, 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 and here. So if we count it, there's 1, 2, 3, 4, 5 times hydrogens here, and only 1 time here. So that means we need to multiply it by 5 here. What we need to do. Oxygen, secondly. It's only once here and twice here. Therefore, we need to times here by 2. However, as we have times the whole element by 2, that means we also need to add 2 hydrogens on this side. So we'll go to 5 to 7. Okay, so now we're going to go through this one. It's only once here and twice here. That means we need to times once again here by 2. So I'm just going to write again the 2 here. And once again, we times the hydrogen by 2, and as it's only present once in this molecule, that means we need to add 1 more here. So with a total of 8. Okay, and finally, we're going to look through this element which we have left out, as the rest is already balanced. There's already 1 of this and 1 of this here. So we have 8 of them, only 2 here, so we need to times here by 4. And I'm just going to write again the others. And now we have a fully balanced chemical equation on this final line. We are now going to find the molar mass of the reactants and the number of moles using this formula that I pre-wrote here, and their atomic mass of each of the elements that you can find in the periodic table under the name of the element accordingly. So, number 2. First we use this formula. So, we know the mass, we have them here, and we're going to calculate the molar mass of each of SO2Cl2 and HI. So we're going to start with SO2Cl2. And here, this one is equals to 32. There's 1. There's 2 oxygen, so we times by 2 by 16. And there's also 2 chloride, so 2 times 35. This gives us a total of 134 grams per mole. Now that we have this molar mass, we're going to work out the molar mass of hydrogen iodide. Same process again. We're going to look at the number of hydrogen, as there's only 1. We're going to 1 plus the one from iodide, which is 127, for a total of 128 grams per mole. Here we are. Now, as we have no more space on the board, we're going to erase this and then go through the third step. Okay, so now we're going to go through the third and fourth part, as we've just done the second part, and obtain these amounts of moles for both molecules, which are SO2Cl2 and HI. So first, in order to find the limiting reactant, we're going to use stoichiometric ratio. This means that we're going to divide the number of moles for each molecules by the stoichiometric ratio. So we're going to start for SO2Cl2. So now it hasn't changed because the stoichiometric number was 1. However, for hydrogen iodide, it's going to change because the stoichiometric number is 8. So this gives us 4. Okay, so now that we have both the amount consumed per molecule, we can tell that hydrogen iodide is the limiting reactant as it is the lowest value out of the two. So we're basically going to now base our fourth question on this number. So we're going to calculate the theoretical yield, in this case of H2O. We're going to do we're going to take this value and multiply it by 2, as the stoichiometric number of water is 2, and over 8, because here the stoichiometric number is 8, which is a quarter. 2 over 8 is a quarter. So we do 7.33 times 10 to the power of minus 3 times 1/4, which is equal to 1.83 times 10 to the power of minus 3 moles. And if the exercise asks you to, you can also convert it to grams using, well, reverting that formula, and therefore doing this times the molar mass, which therefore gives you the number of grams. So if we want to obtain that, we're going to do so 1.83 times 10 to the power of minus 3 times now the molar mass of water. Water contains 2 hydrogens, so it's 1 times 2 plus 1 oxygen, 16. So 16 for an overall of 18. So 1.83 times 10 to the power of minus 3 times 18, which results in 3.29 times 10 to the power of minus 2 grams here. Okay, so now I made you an example that you can work it out yourself. And so this is the question. I gave you the quantities and also the atomic mass, that you don't have to research it into a periodic table. And I want you to find the yield of this molecule. So you can now pause the video and then I'll explain how to go through this. Alright, so now first we're going to start by, just like the checklist before, balancing the equation. So on this equation we're going to start with S, as once again it's the most abundant molecule. So here, in order to have the same amount, you have 4, you have 8, so you need to add 6 in order to have 12 on each side. Then we're going to do the hydrogen. If we count it, we have 3 here and 4 here. So the only way, the simplest way to do that is to times here by 4 and here by 3. Then we have to do nitrogen. Nitrogen is a little more complicated. Here we need to change it, times it by 4, and here times it by 4. 3 times 4, which is 12, plus 4, which is 16, and 4 times 4, which is 16. So I'm just going to wipe that out. That is 16. And here it is 12. And now, if you look at the other molecules, we're pretty much, the other atoms, sorry, we're done for the balancing the equation part. So we're now going to move to step 2. And first thing we'll need to do is calculate the molar mass. So, the molar mass, we're going to start with the molar mass of S2Cl2, which is equal to 2 times 32. This is because the atom mass here, as you can see, is 32, and there's 2 of them, and plus 2 times 35. For a total of 134. Now we're going to do the same for NH3. It's 14, as nitrogen has an atomic mass of 14, plus 1 times 3. This is because we have 3 hydrogen atoms, and their atomic mass is 1 for each other, for a total of 17. Okay, so now that we have this, we're going to find out how many moles each of these molecules we have with the respective math we have been given. So we're going to do this by dividing the mass by the molar mass. So for S2Cl2, it's 3.00 divided by 134, which is equal to 2.24 times 10 to the power of minus 2 moles. Then for let me just add this, n of this to Cl2 equals 2, and now we're going to work out the amount of mole of NH3, which is equal to this time 1.00, as we have here, as you can see, 1 gram, divided by 17. So 1/17 equal to 5.88 times 10 to the power of minus 3 mole. Okay, so now that we have this part completed, we're going to step on to step 3, and we're going to do that right here. So if you remember correctly, step 3 is to find the limiting reactant. In order to do this, we'll take the number of moles we have for each of them and divide them by the stoichiometric numbers we obtained above. So, let's start once again the same way with S2Cl2. So it's we obtain 2.24 times 10 to the power of minus 2 over 6. equal to 3.73 times 10 to the power of minus 2. And for NH3, we have 5.88 times 10 to the power of minus 3. So 5.88 times 10 power of minus 3 over, this time, 16. For a grand total of 3.68. Okay, so 3. Here we are. And now we can see that the limiting reactant is, of course, once I gave the lowest value, which is this one because it's to the power of minus 3 and this one's to the power of minus 2. So we'll consider NH3 for the following fourth and final question. So we are looking for this, the amount, the number of moles of this molecule. So we are going to do it in a very simple way again. We're going to take this value, times it by the stoichiometric number of this molecule, divided by the one of this molecule, as it's the one we're using. So, we're looking for moles, yeah, sorry, for Cl, which is equal to, as I said, 3 times 68 times 10 to the power of minus 3 times, so the stoichiometric number was 12 over 16. 12 over 16, which is equal, in this case, to exactly 4.41 times 10 to the power of minus 2 moles. Okay, so now we have the final number of mole, which is what the question asked. You can also calculate once again number of grams, but you have the formula again, so I'll leave you to that. Thank you for watching, and I hope you enjoyed. See you next time in another video. Bye!